this is the sequel. So let's do part 2. Essentially, we're going to look at problems when we go to solve these absolute value inequalities. They end up as a less than or equal to or a less than sign. So part 2 is about less than or equal to. And how that just ends up being a little different, the final result. So let me just show you some background graphically. So I'm going to graph this function, absolute value of x minus 3. So I'm going to graph that in red, and that just says take the absolute value graph and shift it to the right 3. 1, 2, 3, right here. And then the shape is the same. And the goal of this problem, you can see here, is I want to know when is the absolute value x minus 3 less than or equal to 5. And this would be a y value. 1, 2, 3, 4, 5. So that's right here. So when is it less than or equal to 5? Well, the graph is less than or equal to 5 here, and it's all one continuous interval. There's no breaks like there was in the last video. So when it was greater than, I had the two pieces above, but when it's less than, I have this one piece that's kind of below this line of 5. Specifically from here at -2 all the way to 1, 2, 3, 4, 5, 6, 7, 8, all the way to 8. So the answer should be from -2 to 8. Now those get brackets because it can be equal to 5, or it could be less than, but like -2 is fair game. Like let's check. So if I plug in -2, is that less than or equal to 5? It is. 5 is less than or equal to 5 because it's equal to. It just has to be one or the other for it to be true. And it's equal to, so that's good. Would 0 work? Because 0's in that interval, right? 0's in there. Let's do 0 minus 3. Is that less than or equal to 5? Well, I have absolute value of -3. That works too. +3 is less than or equal to 5. And any number between -2 and 8 is going to work. Now that's kind of a graphical background, but let me show you algebraically how we're going to do it. So you're going to isolate absolute value, just like yesterday, or the last video. I don't know when you did it. Absolute value portion. Just have that on your own. Don't have any numbers being added to the absolute value expression or multiplied. Okay, then you're going to set up two cases. And I think this is like the most important part. I'm going to highlight that. That's the part to really watch out for. So that for us, case 1 is as is. So you don't need the absolute value sign anymore. X minus 3 is less than or equal to 5. The other one being x minus 3 is greater than or equal to -5. So remember, you flip both signs. You face the inequality sign the other way, and you make whatever number it was the opposite. So, well, always make it like negative. Now, this is a less than problem. Less than. So the word that actually goes in between is and to solve problems when it's less than. So x has to be less than or equal to 8. And at the same time, x has to be greater than or equal to -2. And so on a number line, if I have -2 and 8, if it has to be less than or equal to 8, that looks like that. Greater than or equal to -2, it has to look like that. It goes that way. But if the number has to be both less than or equal to 8, and at the same time that number has to be greater than or equal to -2, that's what and means. It means both. It has to be this and this. Whereas or in math means, oh, it could be this, it could be that. If it's either, you're good. But in math, and means it has to be both. So your answer is between. So on a number line, you'll kind of connect from the lower bound to the upper bound. So then an interval notation, that is -2 to 8. So those are your three representations of the solution. Just as like a compound inequality, as a number line, and then an interval notation. You're going to want to show all three. All right, let's do 3 more examples. Okay, so I wanted to do an example where the absolute value is on the right, just to clarify what to do there. Well, I'll start by adding 1. Let's get that out of the way. And we have 14 is greater than x plus 2. And you should have some practice switching this. This is really the absolute value of x plus 2 is less than 14. Think about how this inequality sign is telling us that the 14 is bigger. When we switch sides, it should still be telling us that the 14 is bigger. So this is still a less than problem. So when I set up the two cases, it'll be x plus 2 is less than 14. The word that goes in between is and. When it's greater than, it's an or. When it's a less than problem, it's an and. But I didn't decide it was a less than problem until right before I set up these two cases. So that's when you decide. I didn't decide at the beginning, because otherwise I read this from left to right as a greater than symbol, but I decide right before I set this up. So then x plus 2 is greater than -14. Okay, so x has to be less than 12 and greater than -16. So on a number line, now these are non-inclusive symbols, strictly greater than, so that's going to be open circle. So less than 12, so that's this way, greater than 16, so it's going to be in between. So an interval notation, that's from -16 to 12, non-inclusive. So that kind of looks like just like a point, but it is not. It is an interval. So any value from -16, not including -16, all the way to 12, not including 12, would make this equation true. All right, 2 more. So I threw in some wacky coefficients and stuff here. Just to remind you, you can't multiply into the absolute value. And to get rid of this -2, I'm going to divide both sides by -2. Or you could think like multiply by half, whatever you want. So then I have the absolute value of x plus 3 over 5 is, okay, so I'm dividing by a -2. That means I need to switch the sign. Not because I'm setting up two cases, but just because whenever you divide by a negative or multiply by a negative with an inequality, the sign changes. So this is +20. Okay, so this is step 1. All this work just to isolate the absolute value. Now notice I'm keeping that 5 in the denominator. That's in the absolute value. Don't worry about how weird the inside of the absolute value is. You'll deal with that later. So it ends up being a less than problem again, because the absolute value is less than 20. So the word that goes in between is going to be and. So first case, x plus 3 over 5 is less than or equal to 20, and x plus 3 over 5 is going to have to be greater than or equal to -20. So to deal with this 5 in the denominator, you're going to multiply both sides by 5. So you'll get x plus 3 is less than or equal to 100, and x plus 3 is greater than or equal to -100, but then subtract 3. So we have to be less than or equal to 97, but at the same time greater than or equal to -103. So this is inclusive. I have greater than or equal to, so that's a closed circle. 97, less than 97, greater than 103, so that's going to be between. So my answer is going to be from -103 to 97 inclusive. Now all of these 3 things represent the answer. This one, just as long as the word and is in between, the number line, and the interval notation. These problems are fun. Like you do them the same every time. It's fun to do the number lines. let's just do one more case in example 3. Okay, so if you have a fraction out front, like a lot of people are going to want to distribute that and just like make it 1, like 1/2 times 2. But remember, you can't multiply into the absolute value. It changes it. We just have to get rid of that 1/2, and we'll do that by multiplying by 2. Because this 1/2 is attached by multiplication, so we'll multiply by 2. I mean, you could divide by 1/2, but when you divide by 1/2, it's the same as doubling it. Like, how many times does a half go into the number 4? It goes into it 8 times. It's the same as multiplying by 2. Anyway, so 2x plus 7, absolute value, is less than -2. Now, maybe you're remembering from our other examples, when you have it equal to a negative or greater than a negative, something weird's going to happen. And you need to kind of stop what you're doing, right? Freeze, notice that something's weird, and think, what would make this? What could I possibly plug in? Then take the absolute value. So no matter what, this is going to be a positive number. No matter what you plug in, this is going to be a positive number. Now, what type of positive numbers are going to be less than -2? What positive numbers are going to be smaller than, to the left on the number line of -2? Well, things that would make it true are like numbers like -10, -4, -100. But no positive number is ever going to be less than a negative. So this is impossible. So we're going to say no solution. If this was just a little different, and I said, when will that be greater than -2? Every number would have worked. It would have been all the solutions, all real numbers, but less than a negative, not happening. So it's no solution. So that kind of puts them together. And remember, when you have this symbol and you have less than, it's an and problem. And normally your number line looks like this, or open circle. And then you've got greater problems when you mix those together. And that usually looks like this, where you have the 2 separate intervals, like from -infinity to this value, and then this value to infinity. All right.